Okay. Uh, Welcome to the class. Good morning, friends. Today, what we'll do is we'll start with the concept of CNC programming. Now, what do you mean by CNC programming? It is called as Computer Numerical Control Programming. Before starting with the concept of CNC programming, it would be unfair if we do not understand the history or appreciate the history of CNC programming. It all started after World War II. During this, what happened was, during World War II, most of the ammunitions which were to be supplied to the enemy, they were unable to process it in the required time, and they had to face a lot of casualties. So it happened so that America came up with the idea that why don't we produce a machine which would produce large number of goods in a very short duration of time. So if we just go back to the before World War II, between World War I and World War II, Henry Ford, who is also the father of production concepts, he came up with the concept of mass production, wherein large number of cars of similar kind were produced in bulk. So, but they had a problem wherein they had to give it to the customer within a short duration of time. But it was not possible with the normal conventional machines. So, in year 1952, Richard, one of the person, along with MIT, they came up with a machine which was called as a CNC machine. Now, CNC machine is nothing but a machine wherein we have wherein normal machines like conventional machines like lathe, milling machines, drilling machines, and so many are given a control wherein they can do the work as we do on a conventional machine by machine itself. We do not have to intervene in a lot of things. So let us understand what is CNC programming, and also what are the, in today's class I would be discussing regarding, the first thing is prerequisites, basic nomenclatures. Basic nomenclature. Now, what are the prerequisites? For any CNC programming, we should have the proper idea of, one is, I would be discussing this first part, then I would be going to the second part. That is, first is prerequisites. In this, we need to have the proper understanding of machine tool. Now, as I was telling you that MIT started with the CNC machine. Now, what was the CNC machine earlier and what is the present scenario? Let us understand. The CNC machine which was developed by MIT was a machine which had a basic functionalities which were done by the programming. The reason was, in the during that time, even computer had come up, and CNC programming and the development of computers are in accordance, means they are the contemporaries. So it so happened that as there was a development in computers, the same development started even in the CNC programming. Now, if you all remember that that may think you may have to in your home, is that we have cassettes which are having the rolls. If you just see those, there on a roll or a cassettes, we have the recording of songs, videos, etc. Then if you put, the same thing is developed. Now, the first CNC machine which was there had a tape kind of a thing. Tape means nothing but the programming was written on a tape, and the tape was utilized for number of operations. Means, so let us consider an example that I want to produce this component. Now, for producing of this component, whatever operations are required, I put that on a piece of paper and I punch it. Now, punching is like, if you go to any buses, especially Maharashtra buses, there you can see that on a ticket the conductor punches. Now, same kind of punching was done on those paper rolls, and those were rolled and put up as a bundle. But it so happened that number of components which were to be produced were more. It made some industries like Ford had to produce around 5-digit components, means what, more than 10,000. In that condition, preparing that roll storing that roll and utilizing was becoming a huge problem. So what happened was they came up with the concept of numerical control. That is, the data or the programming was taken and it was not programmed on the piece of paper, but rather it was done on a computer. And this how it started the revolution of CNC programming. Now, before going further, I'll just brush up. CNC programming is important concept where it all started after the World War II. In year 1952, Richard along with MIT took up with the project of developing a machine which would do the normal operations which was done on a conventional machines, but in an automatic manner. That was CNC programming. The initial machines which were there, they had programming written on the tape, and the tape were stored and were continuously utilized. But as we all know that during rainy season or during winter, the paper does not go through the printers. The same thing was happening in the problem, and they were getting stuck. And since the paper quality was not so good, because paper technology was also not so good, the paper, they went on deteriorating, and the program which was written went lost. So they came up that rather than writing the programming on a piece of code, you would write it on a computer. So this how the basic idea started. Now, as we all know that CNC programming requires two things, that is prerequisites and basic nomenclature. Now let us understand what are the prerequisites that are necessary in order to write a program. Now for this, first and the foremost thing is we need to know the machine tool. Now, what do we mean by machine tool? Machine tool is nothing but it can be a lathe. Second, it can be a milling machine. Then it can be a drilling machine, honing machine, honing, lapping. Rather than like this, we can write from basic operation to finishing operation. So taking a component from the initial operations to final operations, whatever machines which are available, all the machines can be programmed by using the CNC program. Now, for our understanding or for our study, we are only considering this, because the reason is, if you see the manufacturing industry which is there, around 90% of the work which is done on the milling. Others are also there, but if you are able to understand this, that would help us in your future endeavors. But these very rarely they are used, and they are very specific programs. So our main area is this, but doesn't mean that I'm not going to deal with it. Our main area I would be dealing in these two things. So first one is called as the lathe, and second is the milling machine. Now, as we all know that lathe machine, you have done it in your workshop. Basic operations like facing, turning, then step turning, taper turning. Now the same thing can be done even in the CNC program. But for understanding the programming, we first need to understand what are the basic things which a machine tool has. What do you mean by basic things? Basic thing is not what are the different axes, different rotations or the motions that a machine has, because without this I cannot write a program. Now for this I would come up with the concept of axis of the machines. Axis of machine. So for this, we'll understand a rule. Take a right hand rule. In the case of right hand rule, now here 3 fingers, you place all the 3 fingers perpendicular to one another. Now here the thumb is going to indicate the x-axis. Now I would place this along this. If you just here, that is thumb is placed along x-axis, the index finger is placed around y-axis, and the middle finger represents the z-axis. Now, and rotation about x, that is like this, either in clockwise or anti-clockwise. Now for why are the 3 axes? X-axis is the translational, means what? It is going to move from one point to another, that is x translational. Y again up and down. Then Z to and fro, means from here to next, again same thing. So if you are moving towards the center, it is negative. If you are moving away from the center, it is positive. Similarly, rotation about x Clockwise is positive, anti-clockwise is negative. Now, rotation about y like this is again positive or negative, and rotation about z like this is c. So x, y, and z. Rotation about x is a, rotation about y is b, and rotation about z is c. Now, but having understood this, how should I understand what are the axis of machine and how should I fix this? Remember, in this condition, we fix two axes, that is x and z. Now, first let us understand which is the axis I should fix. Now, if we consider a lathe machine, what are the two important things? We have headstock and the tailstock. Now, let us understand this. Suppose this is a workpiece and this is the headstock. I have fixed it. Now, what is going to happen? This is the tailstock and you are going to rotate, and this is the cutting tool by which we are going to have the different operations. Now, as we are rotating, we are going to get different operations. Now, let us consider the same concept and how should I apply? In this condition, your spindle axis is nothing but the z. So, what I do is I place it like this. So, in this condition, the z, along the z axis, your spindle is coming. So, remember, in any machine, the spindle axis is represented by z. The spindle axis is represented by z, and the axis on which the workpiece is fixed is nothing but the x. Understood? So, I'll just write it here for your understanding. This is the workpiece, and this one is the spindle. Just a minute. So, in this, the axis along which the workpiece is kept is nothing but the x axis, and the axis along which the spindle is there is nothing but the z axis. Now, if you consider this operation or the lathe, just understand this is the headstock, this is the workpiece. So, in this condition, your machine or the workpiece is called this is the spindle, and this one is the workpiece. Now, if you just see here, this x is nothing but the diameter. So, the workpiece diameter is represented by also here the workpiece diameter or the workpiece nomenclature is also represented by x, and the workpiece length is also represented by z. So, in case of a lathe machine, there are only two axes. Remember, in case of lathe machine, there are only two axes which will be utilized for writing the programming. That is, one is x axis and one is z axis. There is no y axis. So, why this is very important? Because if I do not know what are the important axes which are being utilized for writing a program, I cannot write a program. So, the first and the foremost prerequisite, that is for writing the lathe, is this. So, there are only two axes, that is x and z. Now, what is x? X is nothing but the workpiece or workpiece diameter, and the z is nothing but the workpiece length or nothing but the spindle axis. Hope this point is clear. Now, next what we will do is I will go to the milling machine. Now, in case of milling machine, we have three axes, that is x, y, and z. Now, again, in this condition, your x is representing, sorry, z is representing the spindle. In case of milling machine, your z is representing the spindle. Then, what are, I'll just show this on a page of a book. See here, let us consider that this is a bed of a machine on which I have kept the component. Now, here I have a milling machine. Now, in again milling machine, if in the condition, if I keep the spindle as horizontal, the machine is called as horizontal milling machine. If I keep the spindle vertical, it is called as a vertical milling machine. Is it clear? So, in this condition, let us consider I have kept the machine as a horizontal milling machine. So, in this condition, your spindle will be like this. This is the bed. The yellow color part which you are able to see here is nothing but the workpiece on which I am going to do the operation. Now, just imagine that this is the face on which you are going to have some drilling operations or boring operations. So, if in this condition, your spindle is z, x axis is nothing but the length, width is nothing but z, and the height is nothing but a y. So, if you just see here, x and y are representing the geometry of the workpiece, x and y, and it will have certain thickness, and z represents the spindle. So, in case of milling machines, we have three axes, that is x, y, and z. What is x? X is representing the bed axis, y is representing the width, and z is representing the spindle. Now, just observe here carefully. whatever is the condition, your x does not change. Now just understand, this is your horizontal milling machine. I'll put it sideways. See here, if you are able to see here, this is your bed. This is a horizontal milling machine. So what I'll do is, I'll convert a horizontal milling machine to vertical. Now if you just see the x-axis position is not changing. Only what is changing? Either y or z. So in case of horizontal milling machine, what is going to happen? Just understand the different translational motion and rotational motions here. Now the spindle is going to move like this. That is along the x, positive x, negative x, positive y, negative y, positive z, negative z. So I'll just put it once again. Positive x, negative x, positive y, negative y, positive z, negative z. And just also understand the rotationals. Rotation about the x, clockwise is positive, sorry, clockwise is positive, anti-clockwise is negative, positive, negative, again positive, negative. So now why is this very important? Because we have done only 2D machining. 2D machining in the sense means what? I do only controlling the length and controlling the diameter. But if you see milling operations, just understand this, wherein we have to do this face, this face, this face, this face. So all the 4 faces operation has to be done. In that condition, if I do not know the proper orientation or the axis thing, it would be very difficult. So for this, we need to understand all the important concepts. So hope this point is clear. Once again, I'll just repress the axis of the machine. Axis of the machine are 3, that is x, y, and z. X represents the axis on which the workpiece is kept. Z is representing the spindle, and in y is representing the depth. So for lathe machine, there are only 2 axes, that is x and z. Z is going to represent the spindle, and x is representing the workpiece. In case of lathe, x also will represent the diameter of the workpiece, because smaller the in case of spindle only you are holding the diameter, so smaller the workpiece, larger the workpiece, and z also represents the length from where you are going to do the holding the workpiece. Now in case of milling machine, there are 3 different axes, that is x, y, and z. Again, in the z is going to represent the spindle, and x is going to represent the workpiece, and y is going to represent one or more dimension of the workpiece. So as in case of this, I had told horizontal milling machine means what? You have to hold your hand, that is right hand rule, hold your middle finger in the horizontal axis, all the 3 fingers held perpendicular to one another. Your thumb is going to represent the workpiece or the bed of the workpiece, or the bed on which the workpiece is held. Z is going to represent the spindle, and y is going to represent the height. So horizontal milling machine. So I'll just traverse all the things, all the motions. X, positive x, negative x, positive y, negative y, positive z, negative z. That is for horizontal milling machine. So if now what I'll do is I'll slowly make it vertical. So only just if you just observe, only my spindle which was there, I have made it vertical. So in this case again, positive x, negative x, positive y, negative y, positive z, negative z. So this is how the different axes are necessary. Now, so having understood the machine tool, now why is this one more important? Because machine tool will not only the axis has to be understood, but also we'll have to understand the power which is present on a motor. Because you have practically seen it, when you are doing the operations like facing or turning, you could understand the vibrations which are coming onto your hand. But as in case of CNC machines, the machine is operated by a motor. So whatever the torque it is going to come, it is not going to sense, and there might be an accident. So what happens is we'll have to understand what is the maximum capacity we'll have to work on. Usually what is done is 80% of the power is utilized for machining, because 20% is kept as a buffer, because sometimes what is going to happen, we may not have the constant hardness of the workpiece. If in case of the variation of the hardness, the 20% whatever buffer is there, that will help in order to do the operations. Otherwise it might happen that with maximum force if you go, and suddenly if there is a hard material, there is all possibility that either the workpiece gets damaged or the tool gets damaged. So important is, the first and the foremost requisite is the machine tool. So what I'll do is I'll just stand side so that you can visibly see it clearly. So one of the important prerequisites what you have seen is the machine tool. So as I had told earlier, our understanding is, or our thing is only to study milling and lathe. Other things are only we have only brushed through. So in case of drilling machine, again, in case of drilling machine also, we can write the programming. In holing machine also, we can write the programming. But our scope of study is only limited to this. And in that, preferably in this, what I'll be doing, I'll be giving you one simple example on lathe, but most concentration I'll be putting it on the milling machine. So having understood this, we'll go to the next important prerequisites, that is the tooling. So the first prerequisites, we already studied it, is nothing but the machine tool. So the second prerequisites that is there, so the second prerequisite that is necessary is called as the cutting tool. Now, what do you mean by cutting tool? Cutting tool is nothing but the tool which will be used in order to cut the workpiece to the required sizes. Now, in case of lathe machines, what you have seen, we have seen HSS, that is high speed steel, wherein high speed steel tool is taken, it is put on a grinder, and we have got the different rake angles. You have also seen the nomenclature. But in case of CNC, we have a HSS tool holder onto which we are going to fix the carbide inserts, which does the operations. So we need to understand what are the different cutting tools. Now, in case of lathe machines, there are few different cutting tools. In case of milling machine, there are different cutting tools. So what I'll do is, I'll first tell you what are the cutting tools which are present on the lathe machines. First one is single point. I'll write like single point tool, that is SPT is nothing but single point tool for facing, turning, then grooving, etc. For the different operations we have this. But in case of milling machine, the list of the cutting tools is very large. Here we have face mill cutters, then boring bars, drills, then taps, etc. So all the things we need to know, because without this, the reason why is, in case of normal lathe machines, maximum tool the machine can hold is only 4. But if you want to do the automation of this, we cannot only restrict our thing for only 4. So in case of a CNC machine, wherein we have more than 12 tools which the holder can hold, so that tool can be utilized. Otherwise, what happens is, every time the operator has to change the cutting tool and do the operations, wherein your setup time is increasing. Important is, for any production, we have two things. One is processing time and one is the setup time. Always remember that setup time should be as low as possible, so that the processing time will be more, and by which we can produce component in a very short duration of time. So, but if the cutting tool, or if the machine has very limited amount of space for cutting tool, in that condition, just or I'll put it like this. Suppose for the workpiece to do all the operations, I require 10 tools. So in this condition, what is to happen? Only 4 tools were put up in your tool holder. After that, again the worker has to stop. He has to put new 4 tools, complete the operations. Again, new 2 tools. So there are 3 setup times by which your processing time for the component is reduced. So in order to enhance the production, we need to see also that how many cutting tools a machine can hold. This in case of lathe. But in case of milling machines, we call, there is one which is called as ATC, that is called as automatic tool changer. Even ATC is also present on the lathe machines, but the capacity or the capacity of ATC is around 12. But in case of milling machine, the ATC can go up to, the standard are 30, 45, 60, 90. Sometimes they can go even up to 120. But what is going to happen is, if the ATC capacity is very large, the motor, there will be separate motor which will be utilized for this, and the weight of the machine also increases. So presently this there are companies or the machine tool manufacturers, what they do is, they have the ATC, side by side there is a robot. What it does is, after certain tools are utilized, the robot comes and keeps on changing. So your every time the new tool which is to be inserted in the ATC is done by the robot, the utilized tool is taken out by the robot and it is put in a separate container, so that always the processing is continued. The machine does not stop. Then, having understood the machine tool and cutting tool, we also require to know the third important thing is jigs and fixture. Now, what do you mean by jigs and fixtures? Now, in case of machine operations, we need to understand the two things. One is jig and one is fixture. Now, first we'll understand what do you mean by fixture, then I'll tell you what is jig. Now, what is a fixture? Fixture is nothing but once I want to hold the workpiece onto the, suppose this is a lathe bed and this is a workpiece and I want to do the operations. So, how I am going to hold the workpiece onto the lathe bed? It is nothing but you could put a normal clamp, but every time that provision is not there. Sometimes all the pieces have to be done. In that condition, I put a thing which is called as a fixture. Now, what does the fixture do? The basic idea of fixture is that during the operations or during the cutting, the degrees of freedom of the workpiece are made 0. What are the degrees of freedom? Means what? All the three things, whatever you have studied in axis, that is motion along x, motion along y, and motion along z, rotation about x, rotation about y, and rotation about z are all made 0. So that the same thing you might have studied in the case of COM also. The degrees of freedom should be made 0. If the degrees of freedom are not made 0, what is going to happen? Let us understand. Suppose during cutting, if the workpiece moves in x-axis, either in positive or negative, then along y means what? It will slightly tilt like this, and during z. So what is going to happen? Your cutting will not take properly. In that condition, fixture is one of the important part which will hold the workpiece onto the lathe bed and it will assist in doing the operation. So fixture is important. Now, why is fixture is important? Because the fixtures are of two types. One is manual clamping and one is hydraulic clamping. What do you mean by manual clamping? Manual clamping means what? There will be a point on which you are going to place the workpiece. Clamping has to be done with a wrench or by the person or the operator who is doing the operations. But there is a difficulty. The reason is the force whatever is put up by the worker with help of a wrench may not be constant, and that might sometimes damage or the orientation of the workpiece is not proper. But if I want to do this in a very short duration of a time, I use a hydraulic clamp, wherein clamping of the workpiece onto the fixture is done by the hydraulic setup which is present separately. If I on the machine, the hydraulic pistons operate and they will clamp the workpiece. If I off the machine, the pressure is released and the workpiece is loosened, so the component is ready. So by which, but there is one more aspect. Hydraulic fixtures are much costlier and they are very specific. Means what? I cannot use the hydraulic clamping as a general purpose. They are very specific. Mostly fixtures are very specific, but sometimes there might be some modification which we can do with the normal conventional fixtures which are tightened by manually. But if you are going for hydraulic fixtures, they are very specific to the workpiece and there cannot be any modifications. For component to component, they are very specific and they cannot be changed. So, and also a hydraulic fixture requires certain kind of maintenance. If there is during the operations, if the hydraulic pressure loses, it might sometimes that during operation only the workpiece is loosened and there might have accidents which have happened. But that is not the case in case of manual fixture, because you have already tightened it, so there is no possibility of product get loosened. So this is nothing but the fixture. But in case of jig, then what is a jig? Jig is nothing but, suppose on this workpiece I want to do, or example I will consider, if you go to petrol pumps, you can see there is a air filling station. There you have seen a small compressor which is used for filling of the air. There on the side of the compressor there is a cap which is put, and on the PCD there are a large number of holes. Now if you see the large number of holes on any product which I want to do, there can be, if it is a rectangular plate, rectangular coordinates. If it is cylindrical plate, coordinates they might have put, and we do large number of holes. I'll just show it like this for your convenience. Suppose this is a workpiece, and I want to do the holes onto this. If I want to do the drilling of this, in this condition, important is they have the x quadrant and the y quadrant. Every time going on measuring the x quadrant and y quadrant for so many number of holes for every workpiece becomes very difficult. In that condition, what they do is they put a jig. What is a jig? Jig is nothing but a plate. Jig is nothing but the plate. Remember, we usually use jig on a drilling machine. We do not use a jig on a milling machine. In case of jig, what we do is we create a template which will have similar positioning. I put this plate on the workpiece, and wherever the holes are there, directly I go on drilling it, so that we do not measure the quadrants. And the accuracy of the jig is usually in the 0.1, so 100 mm. So that, sorry, no, not 100 mm, 0.1 mm. In that condition, we can usually control the axis. So jig and fixtures are very important. So in case of prerequisites, one is machine tool, second one is a cutting tool, third one is a jig and fixture. Then the fourth one is, which is necessary to be known, is nothing but the maintenance. Maintenance also, because how much is the pressure of pump, what is the, because in case of CNC programming, we will be using coolants, we will be using oils, where as a flushing for components, because if you are going for milling operations where we want to do the large number of roughing operations, wherein we require extra coolant which will be sprayed on the workpiece. For that we require a pump, we require a tank which will have the coolant, and that how is the maintenance done. So these are nothing but the prerequisites which are necessary. Hope this point is clear. Once again, we'll briefly rush through. One is the machine tool. In case of machine tool, we have studied lathe and milling. Cutting tools, we have seen different cutting tools, jigs and fixture, and maintenance. So having briefly understood this, we need to understand the next, what are the basic nomenclature. So first part of the CNC program you have understood, that is prerequisites. Then the second part is basic nomenclature. In this basic nomenclature, as we all know that there is a standard CNC programming nomenclature which are followed by all the machine tool industry. Now, before going to this nomenclature, let us understand on a CNC machine there are standard CNC programming kits, or nothing but the manufacturers who provide the controllers. Controllers are nothing but the kit or controller kit which will convert a normal conventional machine into a CNC machine. So there are large number of manufacturers. First one is, there is a company called Fanuc, which is a US based company which provides the controller. Second, you are all aware of the word or the company called Siemens, that is in Germany. And there is a company called Mazak in Japan, sorry, it is in Japan. They have their own that is called as Mazatral. So these are the nothing but the standard kits which are available. There is also one company called, which is in Germany, that is called as Haldenein. They also provide the controller. So different companies have different controllers, but remember they all sat together and came up with the standard nomenclature, so that there are certain standard nomenclature which everybody has to follow. If there is a small specific thing which is changed, the company manufacturer has to specifically mention what is the change. So the standard nomenclatures which are utilized for writing a programming, I'll be put up on the board so that you can note it down and understand this. So I'll put up this. So here we will be using alphabets, and there are some standard notations. Alphabet symbol and the corresponding function which it is associated with. So first one is A. As I told, it is called as rotational axis of component along x-axis. So second one is B, third one is C, that is again a rotational axis of component along y-axis and along z-axis. That is, these are three. That is A, B, and C. That are nothing but this. A is nothing but the rotational axis of component along x-axis. B is nothing but the rotational component of axis along y-axis. C is nothing but along the z-axis. Then D, as usual, it is standard. That is diameter of workpiece. Diameter. Then E is called as the end of block. Then F, standard is nothing, it is nothing but feed. G is one of the important thing which you should know, that is called as a preparatory code. Preparatory code. So in preparatory code, they go from G00 to G99. So these are the few things. So A, B, C, D, E, F, and G. I'll just rub it and once again write. So, further part. So A is rotation, B is rotation, C is rotation, D is diameter, E is nothing but the end of block, F is nothing but the feed, and G is nothing but the preparatory code. H is nothing but the tool compensation. So here this is I, J, and K are, they have the standard. This is the component of a radius vector along x-axis, along y-axis and z-axis. What is the meaning of this and how it is utilized in CNC programming? That will be understanding when we will be using the concept of interpolation. During interpolation, when we are preparing or writing a program which will have a contour or a circular rotation, during that time we will be using this I, J, and K. Then L is a subroutine title. Subroutine title. These are standard. These are available even in on Google, or even if you go for any standard controller manufacturers, they will have given this all the things. But even then, it is better we understand this. Then this is miscellaneous function. Miscellaneous function. Then N is block number. So N is block number. So I would request that while writing the program, even whatever alpha, this standard nomenclatures or functions you are writing, you better write it in a paper, so that when you write the program, if these codes are on your end, so that you can easily see it and start writing the program. So once again, I'll just tell this. H is nothing but the tool compensation. What is the meaning of this? That we'll understand when we specifically take that word. I, J, K is nothing but the component of radius vector along x-axis, along y-axis and z-axis. Then L is the subroutine title, M is a miscellaneous function, and N is a block number. Block number is nothing but, in case of CNC program, we do not write program serial number like 1, 2, 3. We write each one as a block number, and it is represented by capital N. So that will see while writing a program. So as in today's class I have already told, basic nomenclature will study. In tomorrow's class I'll put up all the G codes and M codes, and we'll take up a very simple example of one program. Once N is over, then we'll go to O. That is nothing but the program identification. P is axis. UVW and also XYZ. So I'll just here I will spare some time. There are some interesting concepts. Now, in any program, we identify program by O. So what we'll do is, example, suppose this is a component which I want to write a program. So what we'll do is, we write capital O, and suppose the part number is 1000. So O 1000 means one should understand that 1000. So the program which is there is pertaining to this component only. So identification is done by capital O. Then PQR, UVW, XYZ are all representing the axis. Now you might be wondering that already XYZ is available. Why should I go for PQR and UVW? The reason is during programming, if you just understand this, there are 4 phases, 1, 2, 3, 4 phases. So every time what we do is, suppose this is I want to do the facing of this part, this phase, this phase, this phase, this phase. So what I'll do is, I'll fix one phase as the reference. Suppose this phase as O, operation 10, operation 20, operation 30 and operation 40. For operation 10 I fix one axis, that is XYZ. Operation 20 I fix XYZ. But sometimes what happens is, the programmer who is doing, he might get confused for which axis to be utilized for what. So there is an option which is given. If the product is very complex, in that condition the operator is given an option that rather than using XYZ, he has an option of using PQR or UVW for different, so that confusion doesn't arise. Because remember, we are not only writing a program for a very simple component, we are also writing a program for the complex components like turbine blades, where they will be using more than 5 axes. For in that condition, using only 3 quadrants or 3 axes becomes very difficult. So that in order to reduce the confusion, these 6 axes can be utilized. Now here R has 2 other different meanings. One is radius and one is the return plane. What is my radius? Whenever suppose I want to go for a circular arc, consider this program or component like this. We have a fillet like this, and I want to go through, and in the drawing they have written R20. Means what? The radius which is there in R20. So component has to rotate, or the cutting tool has to rotate and cut this. In that condition we will be using R radius. Then return plane. What is the return plane? During drilling operations or boring operations, the workpiece or the cutting tool will come and touch the workpiece. It will do the drilling operations, and it will come and stand at some standard point. Standard point is nothing but, what we do is, suppose I want to drill a hole, I do not take the cutting tool and touch the workpiece and start doing the operation, because if I start the workpiece and start this operation, there is all possibility that the drill tip might break. So what we do is we'll start the drill before it is touching the workpiece, and that point where it starts operating is nothing but the return plane. Return plane is nothing but, if I consider this workpiece, there is one standard thing, usually around 5 mm above the workpiece, the drill starts its functioning. So from there, the drill starts rotating. It has given feed, RPM is given, so it starts doing the operation as if it is doing the operation in the workpiece. So this point where the workpiece is slightly above from the wrist is called as a return plane. So this is represented by R. S is nothing but the spindle speed, which you already know. T is nothing but the tool identification number. As I told that in case of cutting tool, we will be using more than 3 tools, 4 tools, and sometimes even 15 tools, 20 tools. So for each tool to identify, there is a number which is called as a which is represented by T. So and remaining is X, Y, Z. So in today's class, what we have done, we have gone for standard alphabets and symbols and its functions. So quickly, what I'll do is I'll also go for some standard notations and their functions. So alphabets are clear. I'll go for now standard notations which are there and their functions. Initially, in today's class, we have only gone through the standard notations, but in tomorrow's class, what we'll do is we'll be utilizing all these things and write a very simple program. Then you might understand this. Initially, you might feel that you may not understand all the things clearly in the first class, but in the next class, where we will be utilizing all the standard alphabets, symbols, and G codes and M codes, we will be able to understand the program. So this is a percentage symbol, this is the asterisk symbol, plus, minus, forward slash, hash, and colon. That is program file name, end of block, now even in the alphabet there was a notation of end of block. What do you mean by end of block? Means what? Suppose a line is over, if I want to go to the next line, how should that program should understand, or the PC should computer should understand? So what we'll do is we put a standard notation like this asterisk sign or the multiplication sign, which will also put like end of block, and also colon, which will also tell that end of block. Means what? The line is finished, so that the cursor has to go to the next line, so the next line has to be executed. So this is addition, this is subtraction, this is divide or skip the block. Skip the block. Then this is loop, this is end of block. Now addition, no one, there is no need to explain. Subtraction, division, there is no need to explain. But skip the block means what? Sometimes what we do during the program, we do not want one line to be executed. So if I put the end of block to one of the notation, so the next that line is getting skipped, it goes to the next line, so that point does not execute. Means what? I'll just tell you the example. Suppose we have done drilling operations, and I don't want that drilling operation to be done. I want next tapping operation to be done. So the line in which the drilling operation is written, I don't want that to be done. So if I put that forward slash, that line gets skipped. It goes to the next line. Tap is taken and does the tapping operation. So, and next one is loop. As we all know, in case of C program also I have studied. So if I want the thing to be run in a continuous loop, or same program to be run continuously, we go for a loop. Then next one is the end of block. So these are the standard symbols. There is one more symbol which is there. End of block is also written by like this. This is also end of block. So with this, we'll conclude today's class. So what we have done in this class, we understood the two important things. One is the prerequisites and the basic nomenclature. In the prerequisite, we had studied regarding the machine tool, cutting tools, jigs and fixtures, and also the maintenance part. In basic nomenclature, we have studied the standard alphabets and their functions, standard symbols and the functions. In the tomorrow's class or the next class, what we'll be doing is we'll have understanding regarding the basics of different standard G codes and their functions, standard M codes and their functions, and one basic simple example of how to write a CNC program. That will be studying in next class. Thank you.